Hello. We're going to work through homework solutions out of section 7.1. So we're working with inverse trigonometric functions now, and the fundamental thing to remember is that inverse trigonometric functions produce angles, and specifically produce angles in certain quadrants. Okay, so let's take a look at this one. Find the exact value of the arc cosine or inverse cosine of -1. So what this means is an angle whose cosine is -1. And if I look at my standard reference circle, okay, a cosine of -1 means an x-coordinate of -1. That only happens here at this endpoint. Okay. However, there are two ways of looking at the angle here. Is this minus pi or is it plus pi? It can't be both because arc cosine is a function, meaning it produces a single result. So by convention, arc cosine produces an angle specifically between 0 and pi. Arc cosine of something is always going to result in an angle between 0 and pi, which means we don't want minus pi, we want positive pi here. So now what we have is a problem involving an arc tangent. So again, what we need to do is understand what that's really talking about. So this is an angle theta. The tangent of theta is √3/3. But remember that the tangent function has period pi, so if I was to plot theta versus the tangent of theta, okay, the graph has period pi with lots and lots of vertical asymptotes. And the standard period for the tangent function is from -pi/2 to +pi/2. So anything that the tangent function does in the interval from -pi/2 to pi/2, it's going to repeat over and over and over again. And we're looking to achieve a value of √3/3. So it does so infinitely many times, but it only does so once per period. So specifically, arctangent of √3/3 is an angle theta in a standard period of tangent, which is from -pi/2 to pi/2, so that the tangent of theta is equal to √3/3. And I actually wrote this as a closed interval, but in the case of arctangent, it doesn't really matter. For arcsine and arccosine, it's the angles that it produces, we really do want to include the endpoints, but for arctangent, it doesn't matter because you can't take the tangent of pi/2 or -pi/2. These are asymptotes on the graph. So we're never actually going to get these endpoints. So for arctangent, it doesn't really matter. If I want to be very accurate about it, we'll go ahead and say, no, we're not including the endpoints. For arcsine and arccosine, you do, however, need to include those endpoints. Okay, so now what we're looking for is something specifically in quadrant 1 or quadrant 4. So somewhere between plus or minus pi/2, whose tangent is √3/3. In quadrant 4, the tangent function is negative. In quadrant 1, the tangent function is positive. And since we want positive √3/3, we are looking for something in quadrant 1. Okay, so what we want is we want an angle so that the sine of theta over the cos of theta is √3/3. Here I can say, for example, that the sine of theta is equal to √3/3 times the cosine of theta by multiplying both sides by cosine. And now I can say, for example, sine squared theta plus cos squared theta is equal to 1. That's a standard trigonometric identity. But instead of sine squared, I'm going to square this. So this is 1/3 cos squared theta plus cos squared theta is equal to 1. When you square √3/3, you get 3/9, or 1/3. So here I have 1/3 cos squared plus another 1 cos squared. So if I factor that out, here we are. And this tells me that 4/3 times the cosine of theta is equal to 1. Cos squared of theta is equal to 1. So cos squared of theta is equal to 3/4. So the cosine of theta is plus or minus √3/2 by taking the square root. Okay, don't forget it's plus or minus. So how do I know which one it is? Well, we're in quadrant 1. Therefore, the cosine is positive. So the cosine of theta should be √3/2. So now what is a quadrant 1 angle whose cosine is root 3 over 2. Okay, that angle is exactly pi over 6. And there we have it. You could have, by the way, if you have memorized your reference circle super completely or you have it in front of you, you may just have labeled a quadrant 1 angle whose tangent is root 3 over 3 as pi over 6, and you could jump right there. But I tend to not keep these reference things in front of me. I just remember a couple of select angles, and the rest of them I just sort of figure out using standard Pythagorean identities. You really shouldn't think that you have to memorize a whole bunch or that you rely on referring to formula sheets. As long as you've got a couple basic things in your tool belt like the Pythagorean identity, and you keep your wits about you, you can figure this stuff out without the aid of calculators and formulas. Okay, so again, we're going to try to find the arcsine of minus root 2 over 2. So we're looking for an angle. Because we're dealing with an arcsine, it's in minus pi over 2 to pi over 2 in quadrant 4 or quadrant 1. And the sine of that angle is minus root 2 over 2. That is what arcsine of minus 2 over 2 means. An angle whose sine is minus root 2 over 2, and because there are many angles whose sine is minus root 2 over 2, we specify the one in between plus and minus pi over 2. Arcsine lives between plus or minus pi over 2. Arctangent also lives between plus or minus pi over 2. Arccosine lives between 0 and pi. It's a slight difference. Okay, so what is an angle in quadrant 4 or quadrant 1 whose sine is minus root 2 over 2? Well, if the sine is negative, we're not in quadrant 1, we're definitely in quadrant 4, and that would be minus pi over 4. All right, now we're looking at the arccosine of the cosine of 6 pi over 7. So let's just call this cosine of 6 pi over 7, we're going to call it x. Remember, cosine corresponds to x values, so if I'm going to choose any variable to represent that, I'm just going to call it x. So then arccosine of x means an angle theta between 0 and pi. Remember, that's where arccosine is going to produce angles. And I want the cosine of theta to equal x. But remember, x was just the cosine of 6 pi over 7. So here's what the question is really asking. What's an angle in between 0 and pi whose cosine is the same as the cosine of 6 pi over 7? I'm looking for an angle whose cosine is the same as the cosine of 6 pi over 7, and specifically the angle must be between 0 and pi. Well, 6 pi over 7 is already in between 0 and pi. So if I just let theta equal 6 pi over 7, sure, there's an angle, it's in between 0 and pi, and its cosine is the same as the cosine of 6 pi over 7. Okay. Now at the beginning of this problem, a lot of people will look at this and they'll say arccosine and cosine are inverse functions, and therefore the two functions undo one another, and I exactly am back to where I started, 6 pi over 7. And that seems to give you the correct answer, but let's take a look. So here we have the arcsine of the sine of 3 pi over 5. Now, if we just jumped forward and said, hey, they're inverse functions and they cancel out and it's 3 pi over 5, and we're very happy with ourselves. In this problem, it happens to be correct, but let's actually think through what's going on here. Okay, so again, I'm going to call this y, because it's a sine value, I'm going to use y. So arcsine of y is an angle theta. It's either in quadrant 4 or quadrant 1, more specifically from minus pi over 2 to pi over 2. And the sine of that angle should equal y, but y was exactly the sine of 3 pi over 5. So I want an angle whose sine is the same as the sine of 3 pi over 5, and that angle must be between minus pi over 2 and pi over 2. But wait, we thought we could just leap forward and say 3 pi over 5. But 3 pi over 5 is not a legitimate solution here after all, because 3 pi over 5 is bigger than pi over 2. So it's not in quadrants 1 or 4. Okay, so I can't just undo these functions after all. Okay, we were a little too sloppy about it at the beginning of the problem, and it would have led us to the incorrect answer. So the sine of 3 pi over 5 needs to be the same as the sine of theta. So let's look at our reference circle, okay? 3 pi over 5 is over here somewhere. It's just a little bit bigger than pi over 2. What we need is an angle in quadrant 1 that points to the same height. If I take this to be my angle theta, now I have an angle in quadrant 1, and the sine of theta is the same as the sine of 3 pi over 5. And we're going to use some symmetry. Specifically, okay, this angle and this angle are congruent. Okay, so, or you could alternately say that this angle and this angle are congruent. So theta is congruent to pi minus 3 pi over 5. On the left of the circle here, here's pi. Then I need to take away all of this, and that was 3 pi over 5. So this missing bit here is pi minus 3 pi over 5, and based on a symmetry argument across the y-axis, this angle, pi minus 3 pi over 5, is congruent to the angle theta that we were after on the right-hand side. And pi minus 3 pi over 5 is 2 pi over 5. So lo and behold, we couldn't just cancel out the two functions. The arcsine of the sine of 3 pi over 5 is actually not 3 pi over 5, it's 2 pi over 5. And this is because arcsine must produce an angle in between plus or minus pi over 2. However, the thing in the middle there, the sine of 3 pi over 5, you can plug any angle you want into sine. Okay, but arcsine will only spit out angles from plus or minus pi over 2. All right, let's take a look at this expression now. We want to solve this for x. So first we're going to divide out the 9. That's a pretty immediate thing to do. The arcsine of x should equal pi over 3 once we divide 3 pi over 9. Okay. So how do I solve this for x? Well, if the left is equal to the right, then the sine of the left side must equal the sine of the right side. So arcsine of x is an angle theta. It's in quadrant 4 or quadrant 1. And the sine of that angle must be x. But that's exactly what we're doing here. We're taking the sine of the arcsine of x. And the one most primary thing I know about the arcsine of x is that its sine is x. And the sine of pi over 3, well, that's just root 3 over 2. Okay, let's try to solve this. So again, we're going to divide by 6. So I get the arc cosine of 2x is equal to 5 pi over 6. So if I take the cosine of both sides, on the left, here's what we're saying. This is an angle whose cosine is 2x. Now take its cosine. What do you get? Well, this was an angle whose cosine is 2x, so its cosine is 2x. Okay, what's the cosine of 5 pi over 6? It's root 3 over 2. And this is 2x, and therefore x, if I divide 2, is root 3 over 4.